Okay, I'm going to start actually with a piece of our developing outreach program just for sort of atmospherics, and then talk you through how the science is developing. I hope to get you excited about the science, and then of course we haven't done the science yet. The cruise is leaving July 26th, and we'll be back September 5th. So this is sort of a preview of where we are right now. And so anyway, I'll start with this outreach program to draw you in a little bit. I have to unplug my microphone so you can hear the sound. It's just sort of atmospherics. But there's a funny story associated with this that maybe I can come back to at the end of the presentation. So let's see if this works. Can everybody hear that sound?
Yes.
Okay.
I don't think it's very loud, Alan. Can you turn it up a little?
Can I turn it up?
Yeah. Oh, now I hear a little bit.
Not sure. Anyway, don't worry about the sound. It's just for fun. Okay, so now my microphone's back. So that was just a little sort of promo piece we did to try to get people interested in the project, and it was also part of selling it to potential outreach partners that would hopefully, contribute and produce some very accessible products for the public. Okay, so we all know why we're doing this. Just the obligatory science background here. Earth's warming, it's going to happen. Pretty much no question about that. All the IPCC stuff, not news to anybody. But a little more detail in the region is, of course, there's a lot of talk in the news about the infamous global warming hiatus and whether that's the end of global warming. And of course, we all think that's not the case. And in particular, even this week in Science, there's a paper out on corrections to global warming histories that says that the hiatus is maybe not so much as we thought it was. And also a discussion in this week's Science about how the Arctic records are not really in those global projections, and there has been no hiatus there. The Arctic is warming and warming fast. And of course, that's everybody involved in polar programs knows about that stuff. So obviously that's an issue. On the left are some of the historical temperature records over the last couple decades. And on the right are model projections. This is a model, multi-model ensemble from a few years ago. And the point of that is, can everyone see my pointer if I move it? Does that show up on the screen?
Yes, it does.
Yes,
okay,
it does,
great.
yeah.
Thanks. And so the point of that is whatever happens in the surface waters, which may actually be not so much, the big warming may be in the shallow subsurface waters, Greenland. This is the Atlantic over on the right, and moving over to Canada on the left. And so a few hundred meters deep is where the big warming may end up occurring in the ocean. And this happens to be a projection for a couple hundred years in the future. But that's, of course, approximately the typical fill depth of water that is entering the fjords, and it's that water that's then interacting with the outlet glaciers and ice shelves. Of course, this is of more than academic interest. For example, the U.S. is just taking on the leadership for its turn in the Arctic Council and is going to change some of the focus of the Arctic Council to address climate issues, which is a good thing. So the main impact that I'm going to focus on, because we're focusing on the ice system, is sea level rise. And, there's a bit of drama here, but anyway, everybody knows that although the short-term impacts of global warming may be more in the temperature end, the long-term impacts will be sea level rise, and they'll be huge. And the paleo record is particularly useful here because we can look at some of those longer-term processes. And for example, it is known there's really not much debate anymore that sea level was 7 to 10 meters higher during some past interglacial events. And the important thing about that, although no past event is a perfect analog to the future, in these past events, the trigger for this sea level change was really just warming of almost a few degrees above modern. And so it's very likely that we are going to cross some of those triggers, that long-term sea level rise will occur, and it will likely be essentially unreversible on human timescales. So, it's time to understand that. And what we don't know is the timing. We think things are going faster than we used to think, and but are there thresholds in the system? Are there particular triggers we have to be aware of? And obviously, this issue of ice shelves, whether in Antarctica or in Greenland, and how the ocean is attacking the ice sheets is key to this. So to some extent, we're doing a process study with Petermann. It's a sort of microcosm of some of these systems, but each system is unique, of course. And so we need to figure out the details of some individual iconic systems to figure out how this works. There are some projections for the future of Greenland, and this one actually is a little bit old, but this is projecting a few thousand years into the future under some scenarios. And don't sweat the details on this, but the point is that if we do trigger irreversible melting, so you think of that as the tipping point idea is becoming popular. That doesn't mean that everything changes instantly. Then the change then becomes a dynamical system that has to adjust toward whatever its new equilibrium is. And it's going to play out, not over 100 years, but over thousands of years, and it will be inevitable. So it means actually a paradigm shift in the way we think about human society and everything, from one in which we basically assume stasis, and then there's some variability, and good things and bad things happen, whatever, around that stasis, to one of continuous change that's going to occur basically on the scale of the entire history of human civilization. So, how we plan our world under continuous change is probably fundamentally different than how we plan our world under an assumption of stasis. And, that sort of hasn't entered real public consciousness, that there's a future beyond the year 2100, as, the IPCC reports tend to focus on 2100, but there is a future beyond that, and it's going to be different. All right, so this project, as Hetty mentioned, this project has a history to it. It actually starts about a decade ago. Well, it probably actually starts back in 2003 when Kelly Faulkner ran a Healy cruise up to the Nares Strait Petermann region. Of course, Petermann Fjord was full of ice then, and it was really a test cruise of the Healy and test cruise of coring on the Healy of the OSU coring group. Took some of the first cores up there, and we realized that in fact there is a paleo record there. We didn't even know that would be true, and a bunch of good work followed from that. But of course, Kelly moved on to NSF, and she left the science planning of this. But we've been talking about this really since 2003. And so this, in 2008 or so, the development of the ideas for the proposal came out. The first proposal submission was 2010. And as Hetty mentioned, it didn't get funded that round. But we did get funded to have a workshop to think about how to develop some of these, you know, mid-scale, I guess you would call it, mid to large scale projects around some of these systems. And so that was in 2011. And I was one of the chairs of that meeting, and we brought together people from, well, it was an international meeting, mostly U.S., but international, thinking about how we want to approach this, because it's sort of, to even address any one of these systems is a larger thing than your typical individual science budget, proposal budget. So anyway, that group met, and we organized ourselves into thinking about how to address modern ocean ice observations, how to address modeling, and how paleo can contribute to the story. And obviously, I'm the paleo part of that workshop. So anyway, there's a whole bunch of recommendations in that workshop report, which is circulated and cited in various places. And but the key thing is an interdisciplinary approach. And then, you know, rather than doing a little bit of everything, try to pick some iconic systems and do a comprehensive study to really understand them. And then key point was to address those systems under their full dynamic range. And that implies doing paleo, where we can see how much change they are capable of, and also addressing enough different systems that we can capture different systems in different parts of their dynamic range. So the Petermann project is obviously a piece of this, where and the part that is moving forward is the paleo part. And so we are going to look at the full range of change that we think this system can display. And a key to this is, of course, international collaboration. We don't think we can do it alone. And this also, the Petermann project has developed into this fantastic international collaboration that is adding tons of value beyond what we thought it would originally. Okay, Petermann is interesting because it's not just a local isolated system. It is connected to the rest of Greenland through a relatively deep channel that you can see here that was actually not known until recently. And it's some speculation about what this is, whether it's a pre-glacial drainage that has now been co-opted by the ice. And, so not a lot known about it, but it's kind of fortuitous because the ice cores, so Neem, Engrip, Northeast Greenland, all these things are actually toward the head of this canyon, which is ultimately one of the sources to the Petermann system, which is up here on the top. So we've got actually a sort of a wonderful beginning to end, top to bottom view of this system from the ice cores in the top out to the sedimentary records at the bottom. Okay, so now originally we thought we were going to be on Healy, and the way this worked out, Healy was booked up, and so magic happened, and thanks, I think, to some hard work on Hetty's part, we ended up on Odin, which is fine, and actually opened up.
I should qualify that actually and say most of the hard work was Renee Crane making it work.
Okay, credit to Renee then. But this started as effectively it was going to be a charter. As I understand it, and then as this got going, Sweden recognized that this might be an opportunity to jumpstart some sort of plans that were brewing for long-term collaboration between Sweden and the U.S. So we kind of became the guinea pig for making this collaboration work, and then I saw an opportunity also to add Swedish expertise to this. They weren't part of the original proposal, but I've known, particularly I've known Martin Jakobsen for many years, and he's very experienced with Odin. And I thought, well, this is a no-brainer. Make Martin a co-chief scientist, and let's you know, whatever the financial agreement is, let's do the best science. And that has proved to be a fantastic decision. Martin is a great collaborator and a great scientist. And so we're leveraging all sorts of interesting and unexpected things that are adding tremendous value. Well, in the end, this has become actually a jointly funded Swedish-U.S. project. There's some of that actual financial agreement has only happened in the past weeks, I guess. I don't know the details of that. This is a model for now what may be a great long-term relationship. So, you know, maybe it's maybe it's luck, or maybe it's skill, or maybe it's design, I don't know, but it's working out great. Okay, so into the Petermann project itself. So there's two elements of this: is working on land and sea. We'll have helicopter access to land, but everything will be staged off the ship. And so on